Okay, so in this video, again, I'm going to demonstrate how you can calculate an equivalent resultant force which is made up of multiple components lah. Okay, so kalau you tengok dalam example yang ini, okay, the jeep crane, this is a jeep crane punya structure, it is subjected to 3 coplanar forces. So tengok betul ke ada 3 coplanar forces? Ada 1, 2, 3. Yes, that's right. And the question asks you to replace all this loading by an equivalent resultant force. So, and the second part of the question is you have to specify where the resultant's line of action intersects the column AB and also boom BC. So macam mana nak buat? Looks like a very long question, but the cara penyelesaian dia is you just follow step by step sahaja. Okay, so the first step is definitely you have to proceed with the force summation. Okay. So macam mana nak buat force summation? Basically you have to calculate the resultant force in the x direction and also the resultant force in the y direction. So tengok everything is in place, semua in the x direction, y direction. Okay, this one yang sengit-bengit ni you have to resolve it into an equivalent orthogonal direction. So if I resolve it in the y direction, it will be pointed downward. Magnitude dia adalah 5 darab dengan, let's say this is my theta. So referring to the small segitiga, the theta will be over here. So this one would be cos theta. So based on the small segitiga, cos theta would be 4/5. Okay, that's great. So accordingly, you have to resolve it in the x direction as well. So in the x direction, it will be pointed to the left. And the magnitude would be 5 sin theta. And based on the segitiga kecil ni, sin theta would be equivalent to 3/5. Okay, now all that is done, barulah you boleh proceed with the vector summation. So let's start with the x direction. Assuming the rightward direction as positive, so let's calculate the resultant force in the x direction. So tengok apa benda yang ada in the x direction. So we have this 6 kilonewton pointed to the left. So in our equation become -6. And then what else? We have this 5 sin theta pointed to the left as well. So again in our equation it become -5 darab 3/5. So ada lagi tak forces acting in the x direction? Tak ada. All that you sum up using your calculator. So you get a value of -9 kilonewton. So -9 kilonewton indicates that the resultant force have a magnitude of 9 kilonewton and the direction of the load is pointed to the left sebab dia negative. Okay, now that's done. Okay, and the next step, let us calculate the total resultant force in the y direction pula. Okay, quite straightforward, assuming the upward direction as positive. So let's find the resultant force in the y direction pula. So apa benda yang ada dekat y direction? You have these 2 kilonewton pointed downward. So because it's pointed downward, in our equation become -2. And then we have another thing over here, which is a 5 cos theta or 5 darab 4/5. Again, it is pointed downward. So in our equation, it become -5 darab 4/5. So you total all that thing in your calculator, you will get a value of -6 kilonewton. So this indicate that the resultant force in the y direction has a magnitude of 6 kilonewton, and because it is negative, then the direction is pointed downward. Okay, so let's say if I were to plot the punya resultant force, okay, if I were to plot the resultant force, the resultant force in the x direction is pointed to the left, which have a magnitude of 9 kilonewton, and the resultant force in the y direction, terbalik is pointed downward. Okay, sorry, let me just delete this again. Okay, the resultant force in the x is 9 kilonewton pointed to the left, and the resultant force in the y is pointed downward with a magnitude of 6 kilonewton. So let's say the question asks you to calculate the resultant force of all this resultant force. Maknanya dia nak tahu what's the magnitude of the resultant force over here. So since kita dah tahu the magnitude of the resultant force in x direction, kita dah tahu the magnitude of resultant force in the y direction, kita nak calculate this one is quite easy, whereby the magnitude of the resultant force is equivalent to is equivalent to the magnitude of resultant force in the x direction kuasa 2 tambah the magnitude of the resultant force in the y direction kuasa 2, and then you square root everything quite conveniently. Okay, so over here the magnitude is negative 9. Kalau kuasa 2 dia akan hilang negatif dia, tambah dengan magnitude in y is negative 6 kuasa 2, square root everything. So you will get the magnitude of your resultant force to be 10.8167 kilo Newton. Okay, sorry tak muat, so saya macam squash up everything over here. Okay, let's say again, if you are required to look for the direction pula. Okay, macam mana nak cari direction? Let's say taking this angle to be theta. So, using the trigonometric function kan? Okay, so you boleh guna relationship sine, cos or tangent, up to you. So, normally saya pakai tangent lah. Tangent theta. Tangent theta is equivalent to the opposite. Opposite in this case adalah 6 bahagi dengan sebelah dia, which is 9 kilonewton. Okay, so you can get a value of theta to be 33.69 degree. So the direction of the resultant force must always be measured from positive y-axis over here. So you kena tambah dengan 180 darjah. So the direction of the resultant force, theta of the resultant force adalah bersamaan dengan 180 darjah tambah dengan this remaining theta yang you kira tadi, which is 33.69 degree. So you will get a value of 213.69 degree. Okay, so that is how you calculate the force summation or the resultant force of the whole system. Okay, so the second part of the question, dia tanya you specify the resultants line of action. So bila kita nak specify the resultants line of action, sama macam exercise sebelum ni, you kena convert every single force ni jadi moment, and then you kena create dia punya moment summation. Okay, so macam mana nak buat tu? Okay, basically let me just copy this picture. Okay, let me just copy this picture sekejap. Okay, copy. I'm going to put it over here so that it's easy for you to refer. Okay, so this is the original picture. Okay, now if I were to resketch the resultant force. Okay, let's say this is my jeep crane. Okay, so this is a simplified free body diagram. In the simplified free body diagram, basically kita tak tahu where is the location of the resultant force. Tapi the hint is that dia cakap you have to specify the resultant line of action intersects the column AB and also boom BC. So, they wanted to know where is the line of action dekat column AB. Kalau you tengok, this is column AB, this one. So, they wanted to know what's the line of action along here and also along here. So, let's say the first one kita calculate about boom AB ni dahulu. Okay, so let's say the resultant force yang kita kira tadi, okay, pointed to the left is 9 kilonewton. I'm using that magnitude yang kita dapat, and then in the y direction is pointed downward with the magnitude of 6 kilonewton. Okay, so this is the punya resultant force tadi lah yang kita dah kira, which happen to be about 10.8 kilonewton. Okay, so sekarang ni kita nak cari dia punya distance ataupun relatif kepada point X ataupun point Y. So let's say kalau kita kira relatif kepada point A, okay, along AB ni kita tak tahu distance dia kat mana. So let's say kita kira relatif kepada point A. Okay, so ambil point A kat sini. So kita nak tahu the distance over here. What is the D? Ataupun let's just call this angle okay, dy lah, dy to indicate the distance in the y direction. Okay, so again sama macam previous exercise, you are required to compare dia punya moment summation between the original free body diagram and the simplified free body diagram. So the second step is basically you apply the moment summation. Okay, so the moment summation, assuming the counterclockwise direction as positive, so kita kena cari the resultant moment relative kepada rotation point A. Okay, kita take point A, so kena sama dengan the summation of moment based on figure 1 relative pada point A. So remark yang belah sini is based on the original free body diagram, which is figure number 1. Yang belah sini is referring to the simplified free body diagram, which is based on figure number 2. Okay, so now berbalik kepada kita punya ni, referring to figure number 2. So kita convert all the loads into an equivalent moment. So recall balik, moment sama dengan F darab D. So kita punya relative position ataupun the rotation point kita refer in reference to point A. Okay, so therefore dalam based on figure 2, okay, kita nak convert this 9 kN. So load dia adalah 9, perpendicular distance dia adalah kita tak tahu. So just leave it as it is. So the strategy is that salah satu load ni kita letak dia betul-betul dekat middle of the line, so that kita boleh cancel out masa kita nak calculate the moment. So in this case, kalau you tengok 6 kN ni, kalau kita nak convert dia jadi moment, it passes through the rotation point A. So therefore dia tak ada distance. So bila dia tak ada distance, there will be no moment created caused by this 6 kN. Okay, so that's done. So this equation you kena sum up with all the moments happening dekat figure 1 at the original free body diagram. So again, this is our reference point. Okay, point A, rotation point A. So let's convert this one dahulu, this 6 kN. So magnitude dia adalah 6 kN, and then distance dia would be perpendicular to the rotation point, it would be 2 meter. Okay, so tengok what are the direction produced by this 6 kN, counterclockwise. So kalau counterclockwise, in our equation become positive. Yang tadi pun dalam kita, yang 9 kN ni pun is counterclockwise, so it become positive. Okay, and then now that's done, move on to the next force, line of force. So this 2 kN nak convert jadi moment, you kena multiply dengan perpendicular distance. So tengok perpendicular distance dia adalah 1 meter. So letak sini. So what's the direction of the moment produced by this line of force? It would be clockwise. So kalau clockwise, in our equation become negative. Okay, and then this 5 kN, alamak saya tak tercopy dia punya x and y direction dia tadi. So let me just rewrite balik. Magnitude dia adalah 5 darab 4/5, and this one adalah 5 darab 3/5. Okay, so now convert all this into an equivalent moment. So kalau saya convert this one dulu, okay, the magnitude of the force adalah 5 darab 4/5. So what is the perpendicular distance relative kepada rotation point? It will be here. 1 plus 2 will be 3 distance dia. Will it create clockwise or counterclockwise motion? Ini adalah clockwise, so dalam equation akan jadi negatif. Okay, that's done. And then jangan lupa kita ada lagi satu kat sini. Okay, lagi satu line of force over here, which is pointed to the left, and the magnitude adalah 5 darab 3/5. Okay, so what's the perpendicular distance relative kepada rotation point A? So this is the perpendicular distance would be 4. 2 tambah 2 jadi 4. Will it create a clockwise or counterclockwise motion? Macam ni, it will be counterclockwise. So in our equation, it will become positive. Okay, so now kita dah convert all the forces into an equivalent moment. Okay, ada moment tak sini? Tak ada. Kalau tak ada moment, so that's about it. That's our equation. So basically, since there is only one unknown in our equation, so you can calculate the value of dy. So dy adalah bersamaan dengan 10. This one you tekan calculator, you get a value of 10, and then bahagi dengan 9, you dapat dy distance y ni to be 1.1111 meter. Okay, so that is the apa tu nama distance along beam AB along column AB. Okay, yang ini settle. Tapi dia juga nak tahu where is the resultant line of action intersect at boom BC juga. Okay, the second part. Sudah macam mana? Okay, based on the principle of transmissibility, basically you can actually shift the line of force ni, okay, the line of resultant force ni to the other side of the structure as well. Kira macam you anjak sajalah. like you translate it. Okay, so kalau kita anjak this resultant force in the x direction, sama juga 9 kilonewton pointed to the left. In the y direction, sama juga 6 kilonewton pointed downward. So this time around, dia nak tahu what is the line of action along column B, C pula. So again, method dia sama. So it depends you nak reference point dekat mana. So let's say you nak pakai reference point A boleh, you nak pakai reference point B boleh, you nak pakai reference point C pun boleh, tak ada masalah. So let's say saya pakai reference point, still saya pakai reference point A. Saya still pakai the rotation point, reference point of the rotation to be at point A. Okay, so repeat balik the same concept. Okay, so in for the third part, kita still pakai moment summation, tapi in reference to point A. This time around kita kira along beam BC. Okay, yang jalan kerja ni tadi ialah untuk along beam ataupun along column AB. Okay, the second part ni kita nak tahu what is the distance along beam BC pula. Okay, so in this case kita nak tahu the distance along beam BC. We want to know what's the relative distance from here to here. Okay, so let's call this distance to be dx. Okay, so repeat the same calculation. Okay, so di mana you compare the resultant force from the simplified free body diagram dengan the resultant force at the original free body diagram. So basically, kalau you refer to the second figure, this time around tengok dekat yang ini sahaja, tengok dekat yang atas ni sahaja. Okay, so let's say kita nak convert di 6 kilonewton kepada moment. Again, kita still pakai moment summation. So magnitude dia adalah 6, distance dia is unknown, so kita pakai dx. Okay, but kalau tengok dekat sini 9 kilonewton relative kepada rotation point, ada distance. So jangan lupa this one is 9 kilonewton. Perpendicular distance dia adalah, tengok kat sini, adalah 2 campur 2, it will be 4. Okay, will it create a clockwise or counterclockwise motion? So kalau tengok sini, dia akan create a counterclockwise motion. So therefore over here dia akan jadi positif. Okay, tapi yang 6 ni tadi relative pada point A, what kind of direction? Dia akan create clockwise motion. Jangan lupa letak negatif dekat kita punya equation moment di sini. Okay, so basically we've converted the two loads into an equivalent moment. Okay, now you sum up dengan compare dengan the free body diagram of the original figure. Okay, and basically apa yang kau buat ni, you dah kira dekat atas ni tadi, you dah kira this is the thing. So saya just akan guna pakai benda yang sama, saya akan guna magnitude yang sama. Okay, which is 6 kali 2 tolak 2 kali 6 is actually the same thing. 5 kali 4 per 3 darab 3, sebab it is moment relative kepada point A. Okay, rotation point dia adalah pada point A, so it's actually the same thing. Alright, so now there's only one unknown sahaja. You can work on this on your own. Boleh you cari the dx punya value. It will get a value of 4.3333 meter. Okay, so basically this is how you find the location of the resultant force along a specific direction. Okay, so good luck and all the best.